This is the ROS Developers Podcast, episode 102.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the program, the podcast that give you insights about about how to program your robots with ROS. This guy who is not doing properly the intro is Ricardo from the Construct, and today I would like to dedicate this episode to all of you that are thinking about your configuration, the proper configuration for developing in ROS. So which IDE should I install? Which plugins should I put it there? I understand that every programmer has his own taste. So maybe some of you would like to use a VI, and I don't understand why, but some of you want. Awesome. Then others want to use Eclipse. Others want to use, maybe check on the title of this podcast. Some other. So anyway, so you have been considering using your own IDE and are looking for one good option for that, then this episode is dedicated to you. And today we are going to talk about this. One of the subjects of this episode is about which IDE to use. Well, one IDE to use. But before going into that, let me tell you about once again, in this year, in 2022, we are doing the Fifth Ros Developers Day. Yes, that's the conference that at the Construct we organize. It's an annual conference. This is the fifth time that we have been doing. And it's an online conference. It's never been on person. It's always been online. So we have a lot of experience doing this. And then we prepare a very, very special experience for you. This is not just going to a conference and listen to a guy that is explaining some things, but it's a learning adventure. And this year we are going into the deep sea. So we are going to start on June 18 at the port of Southampton at the UK. We are going to get inside the USS Alabama ballistic missile nuclear submarine. So we will fit all of us there. And then our mission is to go and learn about how to program robots that, for example, can find the lost city of Atlantis. So we'll go with the submarine until Alpha 7 station, where we are going to be there with listening to 8 ROS experts' presentations. They are going to teach us around 12 hours straight in the day, and we are going to learn a lot, but especially we are going to practice a lot, because during this conference, you will be able to practice with the speakers. So if you want to attend this special event, it's not just the normal conference. It's a full experience, and so check the website. I'm putting the link on the comments there. Also, let me go down here on the screen, and then you can check our last year ROS Dev Day. That was awesome because we went into Mars. So you can check the videos of the previous conference, and you'll see that we had a lot of fun and enjoy, and also we learned a lot about ROS. Some previous speakers in the conference, so you see Steve Masensky from the Navigation 2 project, Luz Pouvel from Open Robotics, from Ben Zmayar from the Ros2 control group, Sid Fever from Canonical, the creators of Ubuntu, or Luca Marchioni from PAL Robotics. Well, you can see some of the sponsors and what the people were saying on Twitter about the conference. It's super cool. It requires a lot of coffee and also of willing to enjoy and to have fun. So if you are ready to depart, here, register here. Also, we are looking for speakers. If you have one you would like to speak at the conference. So the call for speakers is open. And we are a very special conference also in this point too, because we are paying all our speakers 500 euros per presentation, because we value a lot all the effort that you are doing. So consider becoming a speaker. You have all the instructions about how to apply there. And yes, that's what I wanted to tell you. Have a look and check it, because it's a lot of fun. It's very funny. We have a lot of surprises for you there. Okay, so now, having said all that, now it's time that we go back into the podcast interview today. Now, let me introduce you Lou Amadio. Lou is the principal software development lead for Azure Edge Robotics at Microsoft. His team works on ROS for Windows, but he's also leading other adjacent projects related to ROS and Microsoft services. So welcome to the podcast, Lou.
Well, thanks for having me. It's been a while since we last talked, so I'm looking forward to catching up.
Yes, that's right, because we already talked at the ROSCon 2019, I think, the last one
2019.
before the pandemic, right?
Mm-hmm.
Yeah. Are you going to attend by any chance to the one of the year in Japan?
Definitely on the horizon, yes. I need to get my passport renewed before I can commit to it.
Okay. Okay.
But yes,
okay.
that is the plan.
Great. Then we'll meet there.
Absolutely.
Okay.
I'm looking forward to it.
Great. Great. So then for the audience, then I would like you to explain a little bit about your work, because you work for Microsoft and you work with ROS. So what can you tell us about the status of ROS with working on Microsoft systems?
That's a fantastic question. I've always viewed a robot as the ultimate intelligent edge device. It is something that needs to consume the environment, make decisions about it exceptionally quickly, and act on the environment. That is the quintessential edge solution. Cloud is there to enhance the robot, but not necessarily drive and make the make the decisions directly on that robot. So through the Azure Edge and Platform team, which is ultimately where my organization reports up through, it's all about the edge, devices up through to the cloud. We build solutions for controllers, for single board computers and controllers that work on the device. We build solutions that work on-prem, usually on hosted data centers, and we also build solutions for the cloud. So the Azure Edge Robotics team is building solutions or enabling solutions that operate from that controller to cloud pipeline.
Okay, and in all this pipe, where is ROS related? So how can ROS interact with those services?
That's fantastic. So ROS is a fantastic distributed solution. It works great on device, and it also works great on-prem, between robots or between a robot and on-prem solutions. So Microsoft has been contributing to ROS since 2018. Which is where we first announced it in Madrid at ROSCon 2018.
We met the first time, was there, I remember.
That's where we first met. And before that, we were also engaged with the ROS Industrial Consortium. So went to the ROS Industrial Consortium meetings before that. The real question was, sorry about that. The real question was, what could Microsoft do to enhance robotics on the edge? And that's where we started the question of how do we actually engage with the robotics community, and more specifically with the ROS community. At the time, ROS2 was very young, and a lot of new projects were coming online with ROS1. And we heard a lot from the community that we've been prototyping with ROS, but when we go to put it in deployment, we have this impedance mismatch between the robots that we're building in the environment or in our labs and the ability to deploy them into the ecosystem. And we really want Microsoft's help here so that we can have a trusted environment to run ROS1 in these in deployment.
Uh-huh.
So that's where we started. We actually started by looking at ROS1 and saying, okay, what can we do to enable the systems, subsystems, components, UI, and ecosystem to reduce the friction of bringing these robots from the lab into production.
Mm-hmm.
So that's what we announced at ROSCON 2018 was support for ROS1 on Windows. We are all in on ROS2. Love ROS2. It solves a lot of the problems that people hit with ROS1, and it's also, by its very nature and the way it's been developed, industrial ready. It's been deployed all in so many different places, from space to military to warehousing and logistics. So we are all in on ROS2. We've always looked at ROS1 as a bridge to bring people from ROS1 to ROS2 through our work on ROS1. So that's what our goal has originally started off was to reduce that friction of bringing solutions to market through ROS1 and now into ROS2.
Okay, and when you mention about reducing friction, you mean because many of the computers in the market and most of the users, they are using Microsoft Windows, right? So it's more natural to bring ROS into Windows because the base is very big than the opposite, right? To make people to learn Linux and ROS for products.
Well, so Microsoft is all in on Linux. Like, let's be clear. Like, we've publicly stated Microsoft loves Linux and we support Linux in various different ways. The Windows subsystem for Linux with the Windows 11 has some really amazing support, and we can talk about that a little bit later.
Okay, I didn't know
But
that.
yeah, it's pretty cool if you want to check that out.
Great.
But we also, when you want to deploy a robot in factory environments, many, I wouldn't say most, but many factories and warehouses actually are IT managed using a Windows-based infrastructure. So having ROS on Windows means that the roboticists aren't serving as the IT or OT in deploying these robots into the factory. They can leverage their existing IT infrastructure. That said, Linux is making a bigger inroads, and there might be an inflection point at some point, but our goal is to go where our customers want to go, meet our customers where they want to be, whether it's on Linux or Windows. And in this case, Windows simply wasn't part of the solution until Microsoft stood up and said, we will support ROS1 on Windows. ROS2 is natively supported, and Microsoft contributes to it. So it's the best of all worlds.
Okay. Now then I think I understand. Then to clarify for the audience, then for ROS1 for Windows, it was developed by Microsoft, and then
it was enabled by Microsoft. It was developed.
Enabled. What's the difference?
Made implies that we actually wrote a ton of code to produce this. But the ROS ecosystem already existed and the code was relatively portable. So what we did for ROS1 was make it build for Windows. And then create release packages for it. So it was built relatively portable in the first place. We just kind of pushed it over the edge.
I see.
And then put our stamp and said Microsoft supports this, and we actually have enterprise support solutions for ROS1 on Windows.
Okay. So now I understand better, because so that's a problem I have with the words, with the labels, and then it's my own knowledge of those words. For example, I also had this problem with distribution and version. So for me, it's the next version, but it was Tuli Food from the Open Robotics that I was interviewing him, and he clarified to me this: it's not version, it's a distribution. It depends when you're talking, but for example, Rosnoetic is a ROS distribution. It's not a ROS version. So, and then this is clarifying ourselves the language that we should use properly. Okay, so
I was a little bit of a stickler on the language
Oh.
only because we didn't want to imply something that it wasn't.
yes, exactly.
Yeah, and that's, anyway.
Yeah,
Yes,
yeah, I
we
understand.
want
So
to make sure that
nobody
we don't
offended.
offend anybody.
Yeah, exactly. Yeah. So please, nobody gets offended. It's my own non-knowledge of those things and then very good clarification by you, Lou. Thank you very much.
Absolutely.
Then let's go. So, okay. So you have been talking about Azure Edge Robotics, and also actually you are the leader of this. And what is that, and what is its goal?
Absolutely, that's a great question. So I actually was playing around with the name for our group when I coined the term Edge Robotics. You kind of hear a lot about cloud robotics and the idea that the cloud is part of robots, and that's absolutely true. The question really is about where's the center of gravity of any solution? Is it device native? Is it cloud native? Or is it edge native? And that's where we're coming in saying a robot is a complex hierarchical control system that has time critical components, time critical control loops, but it also has control loops that aren't necessarily time critical. For example, you might store in a cloud solution, hey, I need this part made, and these are the operations that need to be performed, and that's stored in your cloud solution. The fact that you actually need to operate on frames from a video camera, run it through an Edge ML solution that generates control paths, those are time critical because the environment is dynamic. I liken it to playing a video game, a massively multiplayer video game. You're running around and you're about to like hack somebody with a sword, and then they jump, right? That's because there's a latency between what your computer views and what the server sees, and it's trying to compensate by actually changing the world around it. A robot can't do that. The time moves forward constantly. So it has to be able to respond to the environment in a time critical control system so that it doesn't injure anybody, damage infrastructure, destroy product. That's where these edge solutions really are important, because the robot needs to be able to make those decisions independent of what's happening over here. So an edge native solution really acts as a torque converter between the high frequency, low latency, high bandwidth operations that are happening on the robot and the things that are happening on the cloud, which is, did I build this thing? Is it getting ready for deployment? That's why I talk about edge robotics, which is that it's the center of gravity is edge down, as well as cloud up to the cloud. It acts as that torque converter.
But when you say edge, do you mean edge includes the local computer that the robot is running with? So like a bag, and it's also including all the other local computers that may be in the same local network of this? Or how do you do where do you do the division? What belongs to edge and what doesn't?
Well, it really depends on what the scenario that you're building for is, whether it's a thin edge or a thick edge or a really thick edge, or I think there's devices that occur right where the sensor's input, that razor edge, if you will. And then edge solutions can be quite large, encompassing multiple different levels on-prem before you actually transition to cloud native solutions. And that's, the edge is that thick area that happens on-prem down to individual devices. And how do you actually deploy and update and synchronize and all of that?
Okay, and when you say on-prem, it means on the premises?
Oh, sorry, yes, on premises.
Yeah, sorry. Just clarifying this for the people, the ROS developers that are there listening, that maybe they are new to the field or they don't have business experience on this. So just to clarify, on the premises means on the place, on the location, on the building where the robot is actually working, right?
That's right.
Okay.
Yeah. And most of our solutions that we are, well, most of the solutions that we have available are on robot itself. So working with the sensors directly, working
Yeah.
with the ML running natively on the robot, the ability to service that robot through a Windows update and Intune manage those robots. So that's the work that we have today.
Oh, okay, and that's including the Azure Edge Robotics services.
So we do have cloud services, which would be cloud native type solutions.
Okay.
So from a cloud native solution, we have hosted virtual machines for ROS, both Linux and Windows, that are designed to work with either GitHub or Azure DevOps for running simulations, what we call continuous simulation.
Mm-hmm.
When you check in code, it can spin up these VMs, run hosted simulation using Gazebo, collect all of that data, and do a pass-fail using the reporting systems through DevOps. So we do have a DevOps pipeline supporting those scenarios.
Okay.
It's one of the things that we found when we started working in robotics was that integrations tended to happen late in the development cycle, which is where you've got multiple independent teams who are working on their scenario, and then when they come together, there's problems when they put it on the robot. So our goal with our continuous simulation or continuous integration pipeline for robotics was to build a solution that allowed you to, as people are checking in, they actually are running simulations, real simulation, hosted simulations that can scale out to dozens or even hundreds of VMs all running concurrently to allow you to test those scenarios before they actually get onto a robot. Their goal is to reduce the amount of ambiguity during integrations so that when you actually put something into a test environment on a robot, you're pretty good chance it's going to work without having all of the people involved working physically on those robots. So DevOps is a huge portion of what we had done in the time between our last time we talked and this time.
Okay, 2 years. Yeah, almost 3. 2 years and a half.
Yeah,
2 years
and a half. Yeah.
Okay, so that's great. And we can use this DevOps system in order to do functional testing, which means that we deploy the code, and then when the code is deployed, then the simulations, they get started automatically, and then they start to test the code, and also integrate it with the code that somebody else has done in the team and put in everything. And then you can check if everything is on track, or we have broken some functionality of somebody else or something like that. Okay, and then in a massive and parallel way.
That's correct. It leverages a solution called Azure Scale Sets, which is a way of automatically scaling or running multiple parallel VMs as needed by the caller. Azure DevOps integrates with the Scale Set solution. So if you have 100 tests, you can say, hey, I want 100 up to 100 VMs, or you can say, I only want 10 VMs to run these 100 tests, and the DevOps will actually take care of slicing up your test cases to run those in solution. So DevOps was a huge portion of the work that we've done to smooth that transition for bringing up new robots or creating new solutions.
Okay, great.
Our goal is to actually increase the safety of, and reliability and determinism of these solutions that people are producing.
Okay, great. And then let me see here about the questions, because I think that you have answered a lot of them about what's the meaning of Edge Robotics and all that, and the strategy of Microsoft for ROS. So that would be go into this direction, right? Into this direction about providing those tools for the ROS developers that need to develop seriously products, and then they can use the continuous integration environment applied to robotics.
That's correct.
So that's
Yeah,
it.
and these are designed to run in the cloud. So as you're doing your check-ins, you can spin up those VMs either by yourself or through your continuous integration system. So
Oh, that's cool. I had no idea about this, so I'm I'm being acknowledged about this operations and those systems right now here as you, the listener of the podcast. That's awesome. Okay, then let me see. So so we have been talking about the edge and also using the cloud, the Azure cloud, which is the cloud of Microsoft for ROS and robotics. But then we come about the editor, the VS Code, and then so where does it come? So VS Code, where did it started? Is it started on your team?
No, so the Visual Studio Code editor was a project out of our developer division, who's responsible for Visual Studio, which is the full paid development environment for Microsoft. Visual Studio Code is a lightweight cross-platform editor with a very rich marketplace and extension model. It's actually a really cool solution. The marketplace has hundreds, if not thousands, of different extensions that cover topics all over the place, from Rust to Go, Kubernetes. There's even extensions for AI-driven development tooling, which is actually kind of interesting to play with.
Yeah.
But my team is responsible for the Visual Studio Code ROS extension, which is an extension for Visual Studio Code that makes it easier to work with ROS inside of VS Code. It actually started as a project by a ROS community member, Dr. Short, who was working on it many years ago. When we started working on ROS for Windows, I actually went to my friend who works in the developer tooling team and said, hey, we kind of need to do something to make it easier to work on Windows with ROS. We kind of don't know whether we should do Visual Studio or Visual Studio Code. And his suggestion was actually to use Visual Studio Code. So we went and found this extension, and we were going to contribute to it when Dr. Short said, hey, why don't you just take it over and just run with it? So we went through the process of transitioning from his code base to Microsoft hosted. On top of it, we've added a ton of features, not just ROS1 for Windows, but we also added ROS2 support to the extension, plus numerous other features, and we can talk about some of them.
Yes, I would like to know.
You have some questions that you had.
Yeah, exactly. I would like to know what is this extension providing to the ROS developers, because I have to tell you that for the people that comes here to our academy to take courses, the professional courses about ROS and ROS2, then we can see their computers, they are programming in there, and then we can see that most of them, they are using the VS Code as their default editor for programming with ROS. And also outside here, when I visit some other folks from other companies, they are using VS Code. So I think that is becoming the standard IDE for programming with ROS, and people love it. People love it. So for the ones that are new and listening to this, can you explain to them about some of the plugins, some of the functionalities for ROS that you have introduced into VS Code?
Absolutely. I actually have a YouTube channel that is linked to from the ROS webpage that goes into a deep dive of these. But I'll just give a kind of a high level overview of some of the features that are included, as well as some of the things that I have on the roadmap.
Okay. Yes, I will put a link on the show notes here to your channel on YouTube, so people can afterwards go and check the videos, because they are very interesting. They are very practical. They can help you take the most of VS Code when programming for ROS.
Well, thank you. I appreciate that.
Yeah, sure. I have
Uh,
seen it, and you have the same background that you have here in the in the matrix.
I I was learning Unity, so I built this in Unity
Okay, okay.
or Blender. Sorry, I built this in Blender.
Blender. Okay.
Um, as of today, which is April, we have 280,000 installs of the VS Code ROS extension.
Wow.
And as I understand it, the Visual Studio team has said that this extension is actually one of the most used as a percentage of the people who install
Wow.
it. So if you install it, you're likely to use it, which
Okay.
is really cool.
Great.
The there's a couple of different vectors to talk about on the VS Code extension. The first one is that it enables you to monitor the ROS graph in very simply. So is it running? Is it not? Can I start it? Can I stop it? It allows you to interact with the build system. So if it detects that you're running a CallCon workspace, it'll use CallCon for build. If you're using ROS2, it'll use, sorry, I got that backwards. If you're using
Yes.
ROS1, it'll use
Catkin.
Catkin. ROS2, it'll use CallCon,
Catcon. Yeah.
which you can access using Control-Shift-B to build. Those are some very basic integrations. It also, we provided some methods to extract errors so that you can jump to it. So build integration, ROS monitoring integration. One of the bigger early features that we added was debugging support. So on ROS1, you can create a debug target for a launch file. You can now do the same thing on ROS2. What this allows you to do is if you press F5 to launch a debug session, the Visual Studio Code extension will actually crack open those launch files, find the ROS nodes that it needs to launch, and will launch those under the appropriate debugger so that you can actually do step through, put breakpoints on your messages, introspect variables. It's a game changer.
Yes. It's awesome.
But it does this for every single node that is in a launch file. Okay, so if you have a launch file that has 10 or 15 nodes, it'll attach to all of them and allow you to watch your messages transition between those ROS nodes. Works really well when you have a few. We have some features for filtering so that you say, oh, I only want to attach to these couple of ROS nodes or not at all. But the debug system is really designed to attach to all of them. So debugging, huge time saver, especially since you're actually using the launch system. So you get the parameters correct, you get namespacing correct, and those are all passed into the ROS node through startup. So very useful feature. It also has URDF previewing. So if you've ever had a round trip of URDF through a viewer, it can take a long time to build up a robot description. So baked into the VS Code extension, it leverages the ROS web tools to render inside of VS Code a preview of the URDF as you're editing it. So you edit, you save, and it'll reload right there. So your round trip for editing a file is much is reduced. Yeah. So you don't have to go round trip it through a spawn or anything like that.
Yeah, and I can tell you that people love this one. Many people, they tell us, oh, you can see the URDF here inside, so you don't have to run something like a zbot in order to so you can be modifying at the same time and then see the results on the plugin visualization. So in real time, you can be doing modifications.
I'm pretty excited about that one. I have a whole list of features that I want to add to the URDF viewer, like joint simulation. So you get the sliders to move the joints, and the rotation views and things like that. So there are a lot of things that I want to add to that viewer. If you are interested in anything specific, go ahead and go do a +1 on the GitHub issues page and say, hey, I want this, because I'll prioritize work that people want more. I do a lot of the Visual Studio Code development as I'm doing other work, so to make me more efficient, and then I release it for others. And I try and prioritize what people are seeing versus what I need or my team needs. so that we can create a balance. We can get through a lot of the I wish it had X, Y, or Z through that extension. So on ROS2, it actually is a little bit different, which is on ROS1, the launch files are XML based. On ROS2, they're Python based. So we actually have a Python script that it will go and crack open those files. So this is one of the things I'm working on now, is the interaction with the ROS graph, so that you can let me take a step back. When you do a ROS launch on a Python file, that ROS launch is actively executing Python script to manage the life cycle of the nodes. And when you shut down the launch file, it actually shuts down all those ROS nodes. In the Visual Studio Code extension, it doesn't work quite like that. So we need to do some work to make it so that the ROS graph is actively maintained for not just debugging, but for the ability to attach to running instances or monitor. So one of the new features that is coming is the ability to actually introspect and interact with that ROS graph, including attaching launch debugging, restarting a whole bunch of launch files, and monitoring a bunch of different independent subsystems of ROS.
Okay.
So that one's on the backlog shortly.
Okay. Yeah. So please, for all the audience that is there, then go to the link that I will put down here on the show notes, and then vote for those. Are they listed in some way?
Yeah.
Okay.
So in the GitHub issues, there's feature requests and then there's bugs. If you have issues, please do post issues. I'm actively fixing issues and working through things. And for feature requests, give a +1. Hey, I'm hitting this, or I want this, because that'll allow me to prioritize that work.
Okay. Then
the other thing I would really like is if people could give reviews on the marketplace. Even though there's 280,000 users of it, there's only 8 people who have posted
that's typical.
posted a review.
That is typical. This is typical. We are always wanting for feedback, and the people that we are developing material for the community and putting them for free there. But this is a problem that we have here in all the communities. It's very difficult to get feedback from people, even if we know that they are using and they are happy with that. But I don't know. That's difficult. One of the things is that do they have to? So this feedback is on a web page, or it requires to be on the application in a certain configuration?
So it's actually on the marketplace.
On the marketplace, which is a web page. Yeah, okay.
Web page. Yeah.
Then there are no excuses. Then come on. Okay.
It really does help.
Yes, those help, and also they motivate us to continue doing things that are going to be good for you also. So please leave us feedback to Lou and to me also, and to anybody else that is delivering content that you like. We all are going to appreciate it.
Thank you for that.
Yeah, sure. Then let me see about, we were talking about the extensions of VSCode, and any other that you would like to mention?
Yeah, so we have, so on my YouTube channel, I posted some roadmap items that are coming up. Today, there's a couple of different ways to install ROS, ROS1 or ROS2, that work differently between Windows and Linux. One of the new ways of installing ROS is actually through a project called RoboStack, which uses CondaForge. And this is cross-platform, not just on Windows and Linux, but also supports Mac. The way it activates those environments isn't currently integrated into VS Code, although there are some workarounds. So one of the things I'm working on is how to automatically detect and activate CondaForge environments so that you can select the appropriate one for your workspace. So that's coming shortly.
Okay.
The other one that I'm hitting all the time is bootstrapping new Rosnets. I want a new ROS node. There's no file new ROS node that automatically bootstraps it.
What
you can use the.
I don't understand this point.
So in old language, we would say develop a wizard for, you want to create a new extension. Well, what do you want the extension to do? I want it to be, use I2C or UART or USB, and create a new ROS node bootstrapped with code that helps you to fill in the individual
okay,
things.
okay. Yes,
So
pre-built like a template, something.
yeah,
Yeah. Okay.
so ROS node templates, templating system that allows you to build a brand new ROS node and get started right away. Oh, I want to do file new motor ROS node. It
Yeah.
automatically has subscribed to command velocity
Command Bell.
or yeah. So that way you can bootstrap new nodes much quicker by not having to fill out a lot of templated things. So that's something that I kind of want right away because I'm building a lot.
That would be
of
awesome.
nodes.
That will save us a lot of work. And when you are talking about those things, those features, are you thinking about doing this for C++ or for Python? Which are
During the wizard, you'd be able to select it. There's also Rust and Ros2 Net. So being able to select those as bootstrap targets would also be supportable in the templating system. So
Ros2.net, you mentioned.
What are you familiar?
No, no idea. What is that?
So Ros2.net was a project that was started by Estev Fernandez to essentially to support the ROS development in Unity and on the HoloLens. So my team is contributing to Ros2.net, adding support for some new features, and it's an active community investment. This allows you to actually write C# to control your robot, or to build Unity projects that can talk ROS2 natively to a running ROS graph
without requiring a bridge.
Without requiring the bridge, that's correct. The bridge introduces some latency in the messagings because it translates from ROS2 messages to Python to WebSocket to JavaScript
and then back
JSON
again.
And then back again. So with Ros2.net and ROS2 running natively on the HoloLens, you don't have those message translations. It cracks it directly from a binary package into C#, which means the latency and network efficiency is much higher. So yeah, we at ROS World, we did a presentation. This is a HoloLens, so the augmented reality HoloLens.
So you have a HoloLens, and what about this? What does it have to be? Why are you showing me a HoloLens?
Oh, well, so at ROS World, we talked about the Mixed Reality Toolkit, which is a toolkit for building augmented reality applications that can target the HoloLens or other AR devices that with an extension that allows working with Ros2.net. So I mentioned Ros2.net as part of the VSCode extension, but it can actually target Unity, and you can build augmented reality applications that target ROS2. So, and at ROS World 2021, ROS World 2021, we did a presentation on the mixed reality toolkit for ROS2, which is in preview right now.
Okay. So I will put a link to the video because the videos are also published and about for this talk. But I want to ask you then, so why would we like to have an augmented reality for robot development, for robotics, for creating robotics products or robotics research? How can this help us?
Oh yeah, this is a fantastic question. When working with a robot arm, say, you can tell the robot what you want it to do. And today, if you actually are using a tablet, you might have to try and select what, oh, this is the representation of the robot. This is the thing I wanted to manipulate, but it's over there. With augmented reality, you're actually overlaying on top of real space information about the environment. So for example, when you can click in space on the thing you wanted to manipulate, and before it executes, you can actually see a virtual robot that moves through its path on top of a physical robot. So you can actually see through the augmented reality the path the robot's going to take.
Wow.
So that's one of the visions we have for, or one of the visions for augmented reality and robotics.
Yeah, that's awesome.
And
It's like watching RBIS projected on the robot itself, right? Instead of having to have on the tablet or the screen of the computer to watch there the URDF and the sensors, whatever it is. So we would be able, when this evolves, I understand, not yet, but is the progress that is going there, then we'll look at the robot itself, and then we'll be able to see which obstacles it is detecting in real time in the real space, because it will be projected there, for example.
that's correct. At the ROS World demo, I actually did a live demo.
Wow.
Live demos are really scary.
Yeah,
but I did a live demo of.
That's for us, for the brave. Yeah.
Well, when you're writing code at the last minute, you don't have time to record.
Yeah, exactly. That's why it's for the brave.
Yeah, right. So I demonstrated a LiDAR visualization overlaid on top of a robot with a LiDAR on it. I'm currently adding point cloud support, so you can actually see not just linear point clouds, but
Laser.
depth sensors, or I have a Velodyne LiDAR, so you can actually see all of the different LiDAR points overlaid on top of the robot, so you can see where the LiDAR is hitting, if there's any obstacles in the way. Funny story, I was getting a lot of, when I was developing the work stream for that demo, I was getting a lot of points in weird places. And I couldn't understand it until I realized there was a mirror in my room. So the LiDAR was actually bouncing off the mirror and showing up in another place. So this was a case where I was able to debug an environmental issue by actually seeing the overlay on top of real space and seeing that, oh wait, there's a mirror over there that's creating this shadow environment.
Correct.
So I do believe that augmented reality and robotics is going to be a game changer. And I think there's a lot of organizations who are in that same space. What we're building isn't the RViz of augmented reality. They're components that you can use to build your own custom solutions. So companies can build on top of the mixed reality toolkit to build their own solutions, whether it's building a custom integration for some robot deployment, or building your own RViz on top of these components. It does some interesting things around space unification. So holographic space and robot space have to be joined together so that you can create a transform graph from the points that are or from the frames on the robot through a common understanding of space back up to holographic space. Okay. So our toolkit enables that in a couple of different ways. The first is using QR codes. This is a completely offline solution, but we're also working with a team on a cloud solution using spatial anchors, spatial anchor service, where the robot can see space and the HoloLens can see space, and they kind of overlay and create a common reference point through that cloud service. So.
Okay, that's super interesting, and I
can do another video on that.
Yeah. Please, yes. And it's interesting that you mentioned this example about the mirror, and so I can tell you that before it existed ROS, then I was developing robots at a company called Path Robotics, and then we had a problem with a robot that was not able to move on the space. So it was moving normally, navigating, and then suddenly it stopped. And we couldn't see what was happening. Why? Because just the robot just stops, and then you see a lot of messages on the screen of text that is too much, because it's to identify is difficult just by this. So we had to create our own visualization tools in order to see what is happening. And then at the end, we figure out that it was using the sonars for detecting transparent things. So this robot had laser and also sonar. But then the sonars at one specific location or area, they were creating some ghost obstacles because of the reflections in the area and how is it. So the point was there. So we could see that it was detecting an obstacle in there. But in RBase, it's super easy to see, but still, it's a step more because you have to go to the screen and then make the translation between the screen and then what is the reality. In that case, using BR system, then we could see directly on the robot. So we can understand what it's doing now, why it's trying to turn, if it is completely free space or stop in there, right? That's the one of the applications of this.
Absolutely. Yeah,
Awesome.
I'm pretty excited about it. When the HoloLens, actually, a random story, when the HoloLens launched in 2015, I was on the team that built the robot demo for the HoloLens launch.
Okay.
So I actually first tried to use ROS for that project, but because ROS wasn't supported on Windows, and we were actually launching Windows 10 IoT Core at the time as well, I couldn't use ROS for that project. But it was one of the times I was attempted to learn and get familiar with ROS. But ROS is a skill and it's something that takes time to grasp. And once you get that aha moment, it really lights up. I honestly believe that ROS2 is going to lead to that maker moment where adoption of robotics is really going to hit that catalyst and take off. There are some things that need to be fixed in ROS2 to make that happen. Reduction in cognitive load for simple things. Introduction of simple programming techniques that allow you to grow with the capabilities as you learn ROS. There definitely is that wall that you hit in the learning curve of ROS where you kind of get it, and then you have to learn a ton before you can start making progress again. And one of my goals with both our Visual Studio Code ROS extension and some of the extensions to that is to reduce that cognitive load so that people can learn ROS, work with it, and grow with it, and help create that maker moment. So.
Okay. Great. So it's a very good and also a very good goal, and also is aligned with our goal at the construct, because our goal is to teach the people about ROS and how they can in a fast way. So then maybe we can do some things together in order to mix both things. So teaching techniques and also simplifying techniques for developing, and then put something and then make this curve less stepped and faster to reach the maker adoption that you mentioned. That's a good point.
I love it.
Okay, then let me see here. Okay, so I have one question here I wanted to ask you is about
Sure.
What do you think about? So you mentioned that VSCode can achieve so many things for ROS and for robot development. So, but Microsoft already made a Microsoft Robotics Development Studio in the past, and it was not a success. Even if it was a good product, but it didn't reach the point, so it was canceled at the end. So, what do you think? Do you think that VS Code can achieve what Microsoft Robotics Development Studio did not achieve?
It's a good question. I actually worked on the VS Code or the Microsoft Robot Studio in early 2011, 2010,
or even before,
2011.
I would say, even before 08, something like that, I would say.
Yeah, it launched in 2005. So I started quite a bit late on it.
Okay.
And it was actually very successful at the time. It was early in the robotics growth curve for advanced robotics. It was targeting education and early maker, or I guess education and hobbyists, with a transition to industrial. So it was seeing a lot of transitions to industrial scenarios as well. The Robot Studios, it was pretty awesome. It included a simulator message pipeline, message visualization. It was a distributed system that that had a custom protocol for communicating between nodes. A lot of the same paradigm that ROS has.
Yes,
It
exactly.
had in
But
2005.
before ROS, yeah.
Yeah. If you've ever used async await,
Yeah.
the async await pattern, that pattern, I would say personally, was inspired by the generator pattern that the concurrency runtime of Robot Studio used. It was linear. You wrote code that linearly, but it would fork out to tasks. So it looked linear, but it was actually asynchronous, and it worked really surprisingly well as a programming model. It did also have distributed system services, or CCR DSS, distributed system services, which were little tiny HTTP servers that would actually communicate with each other using the concurrency runtime. So it was very similar to the way the ROS works. It turns out, I think this was actually known, but the largest user of Robot Studio was actually MySpace. The MySpace system was built using the distributed system services, the concurrency runtime, and the debugging environment. So you could actually watch HTTP traffic come in from external customers, follow through the system, right out to databases. So it was a distributed system first, robot solution second.
Okay.
It was also the first programming environment to offer support for the Azure, it's not the Azure Connect, the Xbox Connect. So you can actually use the depth sensor in this game engine on robots, and provided simulations for that. They weren't photorealistic at the time, but they were fairly robust physics engine for simulating these robots. It was, again, it was early, targeting very specific early scenarios. But one of the reasons why it was stopped working on it was because how do you actually make money on that? How do you turn it into a product that you can make money on? And there's a couple of different ways to do that. One is to monetize the services on the back end. One is to sell the runtime. One of it's to drive revenue through the things that you're building on top of it. So that's, about that time, the world just wasn't ready for that.
Yeah, I understand. Now in VSCode, the way of monetization.
Now it is.
Yeah, sorry, say
Yeah.
you say.
Yeah, so now the world is. The robots have, or the CPUs, GPUs, they're getting small enough that we can run them on a robot. I mean, this is a Jetson Nano. It's a fantastic board for AI and ML and computer vision and running robots. So we're kind of at that point where robots are capable of doing high level understanding of their environment to where they can actually benefit from something like Robot Studio. And one of the things that I personally love is we decided to invest in ROS as the common substrate for building robots. And I love the fact that Amazon and Google and NVIDIA are all investing in ROS as opposed to building their own thing, because ultimately the customer is going to benefit. You get to choose the system and the pieces, and you can compose them together to build your own solutions. And I think that's underrated, that even though we all compete, that we're all working together on the solution. I really wanted to call that out, but ROS is that common substrate. Robot Studio, we're learning from it. We actually had a bunch of things that were pretty cool about it that I think we can bring to ROS. And I'm trying to with some of the VSCode work streams, but ROS already has a bunch of what Robot Studio was. So yeah, I'm nostalgic about Robot Studio, but highly optimistic and enthusiastic about ROS.
Yeah, it was a pioneer system. It was not the only one. There were others also. Like, I remember that because I was programming the IBO robot from Sony,
Hmm.
and they also built their own kind of ROS system in 1999. They were the super pioneers, but at that time there was no, of course, debugging a program there was terrible. There were no visualization tools, documentation, it was terrible. But there were many, I think that what Microsoft Robotics Development Studio did very well is to integrate everything into a single thing. So it was building the whole framework with documentation, with the simulation, with the message passing, the development environment. So everything was integrated and was very good. But I do agree with you that we were not at the time, at the right moment for that. We were not ready for that. I think it was too advanced, maybe. Yeah, it's a shame. But yeah, other opportunities appear, and then here we are again, right?
Yep, here we are again.
Here we are.
And ROS2 is awesome and
Yes.
And growing rapidly, and it's ready for deployment into commercial environments. So that's what we're seeing.
Great. And so can I ask you about your team, how big it is, and how many resources is Microsoft committing to ROS on Windows and all the other related options or all the related developments that you have mentioned?
Well, I will say that the ROS on Windows team is a small team that did the work to bring it up. That work has been completed. So ROS 1 is complete and in maintenance mode. So we're not actively working on it. We do have resources of working on ROS 2. And we are also working with various open source contributions. I mentioned RoboStack earlier on making it easier to install ROS. So I can't give you a specific number at the moment, but I can say that we are contributing to ROS itself. Plus we have a dozen ROS nodes. DevOps for robotics, we contribute to the GitHub action. We also work on Azure DevOps plus hosted VMs for that, Visual Studio Code ROS extension. And there are some other work streams that we are working on that I can't necessarily talk about right now.
Okay, no problem.
So I can't give you a number, but I can say that we have work streams happening in all of those different verticals.
I see, and then that makes the team kind of distributed and actually difficult to number, because maybe some of the guys, they are working some amount of time on this project, but then in something else, and which is not related to robotics and so on. I understand.
Well, so yeah, I mean, we do have, there are numerous groups around Microsoft who are all contributing to various parts of control systems, autonomous systems, ROS, robotics, and they do have other other requirements in place. My team is full-time on ROS, but I can't give you that number either, sorry. But we do have partner teams who are actively working on robotics and using ROS. So I do spend time working with those organizations as well.
Okay, then let me see. So do you have any idea about how widely is ROS being used on Windows around the world?
Yeah, so for ROS 1 and ROS 2, we actually do keep download numbers whenever they touch our Chocolatey server. We've had, at last count, it was over 300,000 installs from those solutions. We don't actually keep telemetry of the actual use cases, but through other methods, we know that there are quite a few active monthly active devices, although I can't give that number out at the moment.
Okay.
So we do know that there are a lot of users. If you also look at the Open Robotics keeps track of their own use cases, and you can actually see on the ROS metrics site the breakdown of users of operating systems based on usage, and that comes from a different bucket. But when you merge them all together, it's actually a significant number.
Okay, and any real product based on ROS on Windows that you can tell me?
So
I
I can say a lot of the work that we're doing is with customers under NDA. So I can't speak to very specific ones. However, there have been a couple. I don't know. I have to go look to see if what I can share. But there's we do have some press releases that have been done for our work with customers as well as partner teams work with customers, and I can give you. I can see what I can share on those. I should have done that before our conversation today.
Okay.
But
No, but this is a question that I was not included in the original list because I just made it up myself. So, and then I understand it's just by curiosity, just to know, because just to inform the audience about this is just curiosity. It's not important. Don't worry.
well, I can say from our VS Code telemetry about a third of installs are actually on Windows and use VS Code on the VS Code ROS extension on Windows. So of the 280,000, a third of them are Windows.
Okay, a third will be on Windows. Okay, that's quite a lot.
Yeah,
already.
and when I test and release VS Code, I work on Linux and Windows. I don't test on Mac, but I probably should. I've done a bunch of work with containers, remote containers over SSH. I actually build my own personal robots using Jetson Nano and Raspberry Pis. So I do have works. I actively work with ROS on Linux, on the Jetson lines and Raspberry Pi. So
okay.
So
Great.
I do know that about a third of VS Code installs occur on Windows.
What are they doing? We don't know. Okay, we'll see. We'll see in the current. We'll see in the current. In the next months, the next years, we'll see. We'll know about that.
Yeah, it comes back to like the feedback pipeline. What are people using? And do they actually reach out and talk to us about what they're using? That feedback pipeline, as we talked about earlier, you only kind of hear when people have problems rather than whether they have successes. So a lot of what we're trying to do is with outreach is, hey, what are you using? What problems are you having? What can we go fix? What can we celebrate together is part of some of the outreach that I'm doing.
Okay. Please, people, listeners, audience over there, please tell us, give us feedback. So you are doing okay. You are working on this. We'd love to hear from you, and to see that you are doing an amazing project and interesting, developing interesting ideas. So give us feedback. Then final question for you, Lou. So what is your opinion about the future of robotics, and do you think that the robots of the future will run ROS?
So I'm absolutely confident that robots of the future will run ROS. I believe that most robots will include at least one ROS subsystem or component, or have used ROS during their development. ROS2, I'm super bullish on. I believe that it is the right direction. I love the fact that we have multiple different companies who normally compete against each other are collaborating and working on this. So this is something that I'm super excited about. As far as robots in general, I do believe that robots are actually going to enhance our lives. They're going to do those dull jobs or those hard jobs or dangerous jobs that allow us to focus on other aspects of our lives. I believe that robots will help us reduce waste and reduce emissions and actually help us to clean up the environment. I believe that they're going to help us grow food. I mean, they say by 2050, we're going to have 10 billion people on the planet. 2 billion of them go to go to bed hungry today? Can robots help us more efficiently raise crops and get them into markets so that people can go to bed full? And actually, I believe all of this is possible. I'm also really bullish on the idea of micro manufacturing and micro recycling, where manufacturing plants are inside of cities and inside of towns that can make anything that you want, that can take your waste, turn it back into products that you can use to support your community, where we don't have to ship things halfway across the world in order to support these things. So Mike, I do believe that robots are going to lead to these micro manufacturing, micro agriculture, help us to distribute and support humanity. I really am bullish.
Support humanity. Yeah, that's a very cool. That's a very cool sentence that they are going to help us support humanity, and I agree with you. That's the goal, and that's why we are working here, not for other things that are depicted on the movies and so on. So I think that we can do it the other way around in order to be so help us, so they can help us on all those problems that we have. Excellent. Okay, so that's all for today, Lou. Thank you very much for coming to the podcast.
Well, thank you very much for having me. I really appreciate it. I hope it was insightful, and thank you very much for the chat. I appreciate it.
Yeah, so let's meet at the ROSCon 2022 again. Okay.
Sounds good.
Cheers, bye.
Thank you.
And for the rest of the audience, so that is all for today. Remember that if you like this, tell to your ROS developers friends, put us a comment on Apple Podcasts. Well, Apple Podcasts, I think that nobody is using it anymore. I think Spotify is eating it, but I don't know. Well, anyway, give us 5 stars wherever you are listening to this, and send us your comment and your feedback. And well, that's all for today. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.